Okay, good morning students. So in the last class లో మనం ఆక్సిడేషన్ నెంబర్ గురించి ఎక్స్ప్లెయిన్ చేయడం జరిగింది. సో ఆక్సిడేషన్ నెంబర్లో సమ్ ఇంపార్టెంట్ బేసిక్ నాలెడ్జ్ అనేది ఎక్స్ప్లెయిన్ చేసాం. సో టుడే ఐ కెన్ ఎక్స్ప్లెయిన్ oxidation number calculation. So given any one of the chemical compound, so how to calculate the oxidation numbers of the elements. So for example, given KMnO4. In a KMnO4, what is the oxidation number of manganese? So the question is given KMnO4. The KMnO4 is nothing but potassium permanganate. In a potassium permanganate, what is the oxidation number of manganese? This is a very important question in IPE, and so IPE లో మనకి మ్యాక్సిమం దీన్ని 2 మార్క్ క్వశ్చన్స్ లో ఎక్కువగా అడుగుతున్నారు. సో how to calculate అనేది so today I can explain. So first here, how to calculate the oxidation number of magnesium. So first, the potassium oxidation number plus 1. The potassium oxidation number plus 1 because of the potassium is a 1A group of element in the periodic table. So next, oxygen oxidation number is the -2. Oxygen oxidation number -2. So the number of potassium atoms 1. So 1 into potassium oxidation number plus 1 plus 1 manganese atom. So 1 into X plus number of oxygen atoms 4. 4 into the -2 equal to 0. So 1 into plus 1 plus 1 into X plus 4 into -2 -8 equal to 0. So X minus plus 1 minus 8 equal to -7 equal to 0. X equal to plus 7. So X is nothing but manganese. Mn equal to plus 7. So this is the oxidation number of manganese in KMnO4 compound. Okay. So this is a very important example in IPE examination. So next, one more example. You can take sulfuric acid H2SO4. In sulfuric acid, what is the oxidation number of sulfur? Okay. So another example, you can take H2SO4. H2SO4. So how to calculate the oxidation number of sulfur? So here, hydrogen oxidation number plus 1, the oxygenic oxidation number -2. So by using these oxidation numbers, we can calculate the oxidation number of sulfur atom. So 2 into plus 1, 2 hydrogen atoms is there. So that's why 2 into plus 1 oxidation number plus 1 sulfur atom. So 1 into X plus the number of oxygen atoms are nothing but 4 oxygen atoms. 4 into the -2 equal to 0. So plus 2 plus X minus 8 equal to 0. So X plus 2 minus 8, that equal to 6, minus 6 equal to 0. So the X equal to plus 6. X is nothing but sulfur. Sulfur oxidation number. The oxidation number of sulfur in H2SO4 is plus 6. The oxidation number of sulfur in H2SO4 is plus 6. Okay. Next, one more example. K2Cr2O7. Potassium dichromate. In this compound, what is the oxidation number of chromium atom? So for example, potassium oxidation number plus 1, oxygen oxidation number -2. So 2 into plus 1 plus 2 into X plus 7 into the minus 2 equal to 0. Equal to 0. So plus 2 plus 2x minus 14 equal to 0. So plus 2 plus 2x, sorry, so 2x minus 12 minus 12 equal to 0. The 2x equal to plus 12, the x is equal to plus 12 by 2, the plus x is equal to plus 6. Here x is nothing but chromium. So in this compound, the chromium oxidation number is plus 6. So by using this model, we can calculate the any element of the oxidation number in a given compound. Okay. So next, another model. So next, another model is the very important model. So given any one of the compound ion. So given any one of the compound ion, so how to calculate the oxidation number? For example, SO4 minus 2, SO4 minus 2. See, this is not a compound, this is a compound ion because of the charge is present. Here charge is minus 2 charge. So that's why this is nothing but compound ion. So in this compound ion, what is the oxidation number of sulfur atom? What is the oxidation number of sulfur atom? Asking that question. So here, so one sulfur atom is there. So 1 into x plus 4 oxygen atoms is there. 4 into minus 2 equal to here don't write the 0 because of here minus 2 charge is present. So that's why after equal to we can write charge number. We can write charge number. So minus 2. In before example, there is no any charge on the compound. That's why we can write 0. We can write after equal to we can write 0. So but here this is not a compound. This is nothing but compound ion. So because of the charge is present on the compound. So that's why after equal to we can write the charge number. This is a very important point. Okay. So 1 into x minus 8 equal to minus 2. The x equal to the minus 2 plus 8. The x equal to plus 6. So x is nothing but sulfur plus 6 oxidation number. Okay. So here in this compound the sulfur oxidation number is plus 6. Okay. So this is one of the model. So one more example in this model. For example, you can take CO3 minus 2. CO3 minus 2. CO3 minus 2. So this is also compound ion. This is also compound ion. So what is the oxidation number of carbon? In this compound ion, what is the oxidation number of carbon? So one carbon atom is there, 1 into x plus 3 oxygen atoms is there, 3 into oxygen oxidation number minus 2 equal to total charge is minus 2. So equal to minus 2. So 1 into x plus minus 6 plus 3 into minus 2 minus 6 equal to minus 2. X equal to minus 2 plus 6, x equal to plus 4. X is nothing but carbon. So the oxidation number of carbon is plus 4. Okay. So one more example. For example, PO4 minus 3. This is nothing but phosphate ion. Phosphate. This name is phosphate. This name is phosphate. So this is also compound ion. In this compound ion, what is the oxidation number of phosphor? In this compound ion, what is the oxidation number of phosphor? So now also you can take one phosphorus atom is there. 1 into x plus 4 into minus 2 equal to minus 3. So 1 into x minus 8 equal to minus 3. X equal to minus 3 plus 8. X equal to plus 5. So the oxidation number of phosphorus is plus 5. Okay. So this is the different methods to calculation of oxidation number in a compounds. Okay. Now another model is there. Before we have to calculate the oxidation number of compound, and the next model is given compound ion. So how to calculate the oxidation number? So next another model is there in this oxidation number. So another model is the very important model. So in this model, asking about Neet mains examination. This model very important. So what is that model? Given any one of the peroxy compounds. So now I can explain how to calculate the oxidation numbers of peroxy compounds. Okay. So for example, okay. So H2O2. So that is nothing but the compound name is hydrogen peroxide. So in this compound, this compound is a peroxy compound. How to say? So first we know that peroxy per oxygen atoms. First we know that per oxygen atoms. Already you know that oxygen atom. So what is the oxidation number of oxygen atom? The minus 2 is the oxidation number of oxygen atom. But peroxygens, in a peroxygens, the oxidation number of oxygen is not a minus 2. In a peroxides, the oxidation number of oxygen is minus 1. This is a very important point. In a peroxides, the oxidation number of oxygen is minus 1. So for example, this is the hydrogen peroxide compound. This is hydrogen peroxide. So how to identification of peroxygen atoms in a given compound? How to identification of peroxygen atoms in a given compound? So peroxygens nothing but the any two oxygen atoms bonded with one single bond. The two oxygen atom bonded by one single bond. So that oxygen are called peroxygen atoms. That bond is nothing but a peroxy bond. So once again repeated, how to identification of peroxygen atoms in a given compound. The two oxygen atoms bonded with one single bond. That bond is nothing but peroxy bond. That oxygen atoms are nothing but peroxides. For example, H2O2. So you can draw the structure of H2O2. So this is the structure of hydrogen peroxide. We can see in this the two oxygen atoms are bonded by one single bond, or in between two oxygen atoms one single bond is present. Okay, so this bond This bond is nothing but peroxy bond. These oxygen atoms are nothing but peroxygen atom. So in peroxygen atom, the each oxygen having -1 oxidation state. -1 oxidation state. -1 oxidation state. Not a -2. Okay now. So in this oxygen atom, each oxygen having -1 oxidation state. Okay, clear? So what is the meaning of peroxy bond and what is the meaning of peroxygen atoms? Okay, the two oxygen atoms bonded with one single bond. That bond is nothing but peroxy bond. That oxygen atoms are nothing but peroxygen atoms. So in peroxide compounds, the each oxygen oxidation number is -1, not a -2. Okay, so what is the examples? How to asking examples in a NEET and mains examination. So for example, H2S2O8. So this is the one of the most important examples of peroxy compounds. Okay, this is the most important examples. In this compound, the NEET examination asking about so what is the oxidation number of sulfur in this compound? What is the oxidation number in this compound? What is the oxidation number of sulfur in this compound? That is a question. So in before already you know that some of the uh, compound given on of the compound how to calculate the oxidation number. You know that already in before knowledge 2 into plus 1 oxidation number already hydrogen oxidation number plus 1 oxidation number minus 2. This is the basic knowledge in before. Okay. So 2 into plus 1 2 hydrogen atoms is there, 2 into plus 1 oxidation number plus 2 sulfur atoms is there, 2 into x plus 8 oxygen atoms is there, 8 into oxygen oxidation number minus 2 equal to 0. So the plus 2x minus 16 equal to 0. Okay. So 2x minus 14 equal to 0. The 2x equal to plus 14. The x equal to plus 7. The x is nothing but sulfur. The sulfur oxidation number plus 7. This is the wrong answer. So the sulfur oxidation number not a plus 7. The only sulfur exists to three types of oxidation numbers. 2, 6, 4. 2, 4, 6. These are very important oxidation numbers of sulfur. The sulfur exhibit only three types of oxidation numbers 2, 4, 6. So ఈ 2, 4, 6లో తప్పించి మనకి ఏ నెంబర్ వచ్చినా సరే దట్ ఈస్ ద రాంగ్ ఆక్సిడేషన్ నెంబర్ అవుతుంది సల్ఫర్. సల్ఫర్ ఎగ్జిస్ట్ ఓన్లీ దీస్ త్రీ నెంబర్స్ ఓన్లీ 2, 4, 6. Okay, so the maximum compounds the sulfur exists to plus 6 oxidation number. There is no 7, there is no 5, there is no 3. So only exist plus 6 or plus 4 or plus 2. So these three numbers only exist the sulfur oxidation number. So here sulfur oxidation number plus 7. So this is the wrong answer. So why? So because of here this is nothing but not a normal compound. This is nothing but peroxy compound. So that's why the sulfur oxidation number is given wrong answer. Okay. So here you can take all 8 oxygen atoms here. 8 oxygen atoms are you can take minus 2 oxidation number. That's why given wrong answer. Okay. So this is the peroxy compound. So the peroxy compounds means minimum peroxygen atoms is there. So how to identification of peroxygen atoms in this compound? First one of the we can write the structure. First we can write the structure. this is the structure of H2S2O8. Okay. So మనకి ఇక్కడ two hydrogen atoms is there, two hydrogen atoms also is there, two sulfur atoms is there, two sulfur atoms is there, eight oxygen atoms there, 1 2 3 4 5 6 7 8, eight oxygen atoms is there. So but in this structure we can observe the two oxygen atoms bonded by one single bond. These two oxygen atoms bonded by one single bond. So that's why these two oxygen atoms are not a normal oxygen atom. These two oxygen atoms are nothing but per oxygen atoms. These two oxygen atoms are per oxygen atoms. That's why the each oxygen having -1 oxidation state. -1 oxidation state. So remaining hydrogen atom, you can see remaining hydrogen atoms. These remaining hydrogen atoms bonded with one single bond. No, this oxygen atom is bonded with sulfur atom and hydrogen atom. So this oxygen atom bonded two bonds bonded with sulfur atom. This oxygen bond with the sulfur atom. This oxygen bond with the hydrogen atom, bond with the sulfur atom. This oxygen bond with the sulfur atom. Only these oxygen atoms bonded by one single bond. That's why these two oxygens are per oxygen atoms. This bond is nothing but peroxy bond. This bond is nothing but peroxy bond. These two oxygen atoms are per oxygen atoms. The remaining oxygen atoms are normal oxygen atoms. So that's why the remaining oxygen atoms having -2 oxidation state. Normal oxygen atoms -2 oxidation state. Okay. So now you can calculate the oxidation number. So two hydrogen atoms there, 2 into hydrogen at oxidation number plus 1. So two sulfur atoms is there, 2 into X plus 8 oxygen atoms is there. In 8 oxygen atoms, the 6 oxygen atoms having normal oxygen atoms. That's why you can take -2 oxidation number. The 6 into -2. The 6 oxygen atoms, 1, 2, 3, 4, 5, 6. These 6 oxygen atoms are normal oxygen atoms. That's why we can take 6 into -2. And the remaining 2 oxygen atoms is there. The remaining 2 atoms, 2 into 2 oxygen atoms, 2 into each oxygen having -1 oxidation state, -1 equal to 0. Equal to 0. So the +2 and 2 into x, 2x -12 and the 2 plus 2 into -1 -2 equal to 0. Okay. So +2 and -2 cancel and 2x minus 12 equal to 0. 2x minus 12 equal to 0. The 2x equal to +12 and x equal to +6. X equal to +6. So the x is nothing but sulfur. The x is nothing but sulfur. Here sulfur oxidation number +6. So this is the correct answer. The sulfur exists only 2, 4, 6 numbers. These 3 numbers exist the sulfur oxidation number. The remaining any number, that is wrong answer. Okay. So here +6 is the correct answer. +7 is the wrong answer. Because of in this compound is a peroxy compound. This is not a normal compound. Because of 2 peroxygen atoms are there. 2 peroxygen atoms are there. Okay. So given one more example, this type of compound. So one more example, K2S2O8. K2S2O8. So in this compound also, what is the oxidation number of sulfur in this compound? So they calculate the oxidation number of sulfur in this compound. So generally you have to calculate 2 into +1 plus 2 into x plus 8 into -2 equal to 0. General calculation, 2 plus 2 and plus 2x minus 16 equal to 0. So plus 2, so 2x minus 14 equal to 0. The 2x equal to plus 14, x equal to 2, 7. X equal to plus 7. The sulfur oxidation number plus 7. The sulfur oxidation number plus 7 is the correct answer. That is also wrong answer. The sulfur exists only plus 6 maximum compounds. The sulfur oxidation number is plus 6. So that's why this is also wrong answer. Because of this compound also not a normal compound. This is compound also peroxy compound. So because of in this compound also peroxygen atoms is there. So here also write the structure. So structure అనేది మనకి గుర్తు ఉండడం అనేది డిఫికల్ట్ కాబట్టి ఇక్కడ స్మాల్ టెక్నిక్ ఏంటంటే సో ఏ కాంపౌండ్ ఎనీ పెరాక్సీ కాంపౌండ్ తీసుకున్నట్లయితే ఎనీ గివెన్ పెరాక్సీ కాంపౌండ్ ద మినిమం 2 పెరాక్సిజన్ ఆటమ్స్ ఆర్ దేర్. ద మినిమం 2 పెరాక్సిజన్ ఆటమ్స్ అనేది మనం క్యాలిక్యులేషన్ స్టార్ట్ చేయాలి. సో అప్పటికి మనకి రాంగ్ నెంబర్ వస్తే నెక్స్ట్ 4 ఆక్సిజన్ ఆటమ్స్ అని తీసుకోవాలి. సో మినిమం 2 ఆక్సిజన్ ఆటమ్స్ ఆర్ పెరాక్సిజన్ ఆటమ్స్ తీసుకుంటే మనకి మ్యాక్సిమం ఆన్సర్ వస్తుంది. సో ప్రతిసారి స్ట్రక్చర్ అనేది రాయడం అనేది ఇంపార్టెంట్ అనేది మనకు కాదు. స్ట్రక్చర్స్ తెలిస్తే ఓకే నో ప్రాబ్లం. బట్ స్ట్రక్చర్ తెలియకపోతే మాత్రం మనం దాని స్ట్రక్చర్ రాసుకుని ట్రై చేస్తే ఎక్కడ దొరికిన స్ట్రక్చర్ అనేది రాంగ్ చేస్తాం కాబట్టి సో కంపల్సరీగా మనం ఇది ఒక టెక్నిక్ అని గుర్తుపెట్టుకోండి. మినిమం 2 oxygen atoms per oxygen atoms is there. So okay, so 2 into plus 1, the potassium oxidation number plus 1, okay, plus 2 sulfur atoms is there, 2 into x, plus here 8 oxygen atoms is there. The minimum 2 oxygen atoms are per oxygen atoms. You can take 2 into minus 1 plus remaining 6 oxygen atoms is there. The 6 oxygen atoms are minus 2 equal to 0. The 6 oxygen atoms are normal oxygen atoms. The 2 oxygen atoms are peroxygen atoms. So each peroxygen atom is the minus 1 oxidation state. That's why you can take minus 1. Okay. So plus 2 into x, 2x, the minus 2, the minus 12 equal to 0. So plus 2 minus 2 cancel. The 2x minus 12 equal to 0. The 2x equal to plus 12. Then x equal to plus 6. X is nothing but sulfur. The sulfur oxidation number exists plus 6. This is the correct answer. Okay, can you understand? Okay. This is very very important examples of peroxy compounds. So next one more example. This is the very very important examples of peroxy compounds. H2SO5. H2SO5. So normal calculation here also. The 2 into plus 1 plus 1 into x plus 5 into the minus 2 equal to 0. So plus 2 plus 6 minus 10 equal to 0. The x minus, okay, 10 minus 2, 8. So x is equal to plus 8. So x minus, x is nothing but sulfur. The sulfur oxidation number plus 8. In this compound, H2SO5 compound, the sulfur oxidation number plus 8. This is the correct answer. This is also wrong answer. So because of the sulfur exists 2, 4, 6 numbers only. Coming any number, that is nothing but wrong answer. Okay. So that's why this is also peroxy compound. In a peroxy compound, minimum take 2 oxygen atoms or peroxygen atoms. Okay, now 2 into plus 1, 2 into hydrogen atom oxidation number plus 1 plus 1 sulfur atom is there, x, plus 2 oxygen atoms, so 2 into minus 1 plus remaining 3 oxygen atom, 3 into the minus 2 equal to 0. Totally 5 oxygen atoms is there here. Total oxygen atoms are 5 oxygen atoms. Minimum 2 oxygen atoms are peroxygen atoms. So that's what 2 into minus 1. The remaining 3 oxygen atoms, normal oxygen, so minus 2 equal to 0. So plus 2 plus x minus 2 minus 6 equal 0. Plus 2 minus 2 cancel. X minus 6 equal to 0. X equal to plus 6. X is nothing but sulfur. The sulfur oxidation number is plus 6. Why? Because of this is nothing but peroxy compound. In a peroxy compound, minimum we can take 2 oxygen atoms per oxygen atom. Okay, this is the correct method. Okay, so one more example and last example in this model. S2 O8 minus 2 S2 O8 minus 2. So in this compound, this is nothing but compound ion because of minus 2 charge is there. So this is the compound ion. So this is also peroxy bond is there. So first you can take normal compound model. For example, 2 into x plus 8 into minus 2 equal to, the charge is minus 2, that's the equal after minus 2 number. So 2 into x minus 16 equal to minus 2. The 2x equal to minus 2 plus 16. The 2x equal to plus 14. The x equal to plus 7. The sulfur oxidation number plus 7. Here also the sulfur having plus 7 oxidation number. That is correct answer. That is also wrong answer because of sulfur exit plus 6 oxidation number but not a plus 7. So that's why this is also peroxy compound. So in this peroxy compound, minimum take 2 oxygen atoms are per oxygen atoms. Okay. So 2 into x plus 8 oxygen atoms is there. 8 oxygen atoms, 2 oxygen atoms are minus 2 and 6 oxygen atoms are minus 2 equal to the total charge equal to minus 2. That's why after we can write minus 2 charge. Okay. So 2 into x, 2x minus 2 and minus 12 equal to minus 2. Okay. So 2x, so minus 14 equal to minus 12, thus 2x equal to minus 2 plus 14, the 2x equal to plus 12 and x equal to plus 6. X means sulfur plus 6 oxidation number. So this is a very important model. So given any one of the peroxide compound, how to calculate the oxidation number. So this is a very important model. So Neet and mains example లో ఎక్కువగా ఈ మోడల్స్ లో అడుగుతున్నారు కాబట్టి. ఓకే, so given next another model, how to calculate the oxidation number of in a soap peroxides. So in a peroxides, the oxidation number is -1. In a soap peroxides, what is the oxidation number of oxygens? So what is the oxidation number of oxygen in a soap peroxides? Okay, so soap peroxides. So in a superoxides, the each oxygen having -1/2 oxidation number. In a superoxides, the each oxygen having -1/2 oxidation number. For example, you can take one example, KO2. KO2. So in this compound, what is the oxidation number of oxygen atom? Okay, so now calculate K. 1K, 1 into K, one potassium atom is there, 1 into potassium oxidation number plus 1 plus 2 oxygen atoms is there, 2 into x equal to 0. 2 into x equal to 0. So 1 into plus 1 plus 2 into x, 2x equal to 0. The 2x equal to plus 1 after minus 1, x equal to minus 1 by 2. So x is nothing but oxygen minus 1 by 2. So that is nothing but minus 1 by 2, nothing but the oxygen is a not a peroxide, that is not that oxygen is a superoxide. So oxygen having different type of oxidation numbers. Generally, common oxidation number of oxygen is -2. Generally, the common oxidation number of oxygen is -2. In a peroxides, the oxidation number of oxygen is -1. In a superoxides, the oxidation number of oxygen is -1 by 2. The -1 by 2 is nothing but the oxygen is nothing but superoxide. Okay. So one more example. NaO2. NaO2. Okay. So in this also calculate the oxidation number of oxygen. So 1 into 1 sodium atom is there, 1 into sodium oxidation number plus 1, 2 into x equal to 0, the plus 1 plus 2x equal to 0, the 2x equal to minus 1 plus 1 after minus 1, x is equal to minus 1 by 2. X is nothing but oxygen oxidation number minus 1 by 2. The minus 1 by 2 is nothing but that is nothing but super oxide. Okay. So this is the examples of superoxides. We before discuss about peroxides. So next oxyfluorides. In oxyfluorides, what is the oxidation number of oxygen? Okay. So now we can take one example. So in the oxyfluorides, two types of oxyfluorides. The one is the dioxydifluorides. Another one is the oxygen difluorides. Okay. So oxyfluorides. In oxyfluorides, what is the oxidation number of oxygen? So oxyfluorides are two types, dioxydifluorides and oxydifluorides. First we can take dioxydifluorides. For example, O2F2. This is nothing but dioxydifluoride. So in this compound, what is the oxidation number of oxygen? So now can calculate 2 into X plus 2 fluorine atoms there, 2 into the fluorine is a 7th group of element, that's why there is a -1 oxidation number fluorine. The -1 equal to 0. So 2 into x, 2x minus 2 equal to 0. The 2x equal to plus 2. The x is equal to plus 2 by 2. That is equal to plus 1. In the dioxydifluorides, the oxygen atom exists plus 1 oxidation state. So, in a before already explained, the oxygen having different states of oxidation numbers. Okay. So, in a dioxydifluorides, the oxygen having plus 1 oxidation state. So, another model, oxygen difluorides, OF2. For example, we can take OF2, oxydifluoride. So, in this compound, what is the oxidation number of oxygen? So, for example, so 1 into x plus 2 into the minus 1 equal to 0. X minus 2 equal to 0. X equal to plus 2. X is nothing but oxygen. Oxygen of oxidation number plus 2. Okay. So here oxydifluorides, the oxidation number is plus 2. In dioxydifluorides, the oxidation number of oxygen is plus 1. Before, in superoxides, the oxidation number of oxygen is minus 1 by 2. In peroxides, the oxidation number of oxygen is -1. The common oxidation number is the common oxidation number of oxygen is +2. Sorry, -2. The common oxidation number of oxygen is -2. In a superoxides, -1. Sorry, in a superoxides, -1/2. In a peroxides, -1. In dioxydifluorides, +1. In oxydifluorides, +2. Okay. So this is the important models of oxidation number of oxygen atom. Okay. Peroxides, superoxides, oxyfluorides. In oxyfluorides, oxydifluoride, dioxydifluoride. Okay. So last model in this oxygen atom, ozonides. This is the last model. Ozonides. Ozonides. In ozonides, what is the oxidation number of oxygen atom? In ozonides, what is the oxidation number of oxygen atom? So, for example, you can take KO3. This compound is ozonides. This compound is ozonide. In ozonides, what is the oxidation number of oxygen atom? Okay. So 1 into +1 oxidation state of potassium atom plus 3 into x equal to 0. +1 plus 3x equal to 0. So the 3x equal to -1, the x equal to -1/3. The x is nothing but oxygen oxidation number -1/3. In ozonides, the oxidation number of oxygen atom is -1/3. So different types of oxygen atoms is there. The first one, the common oxygen atom, -2 oxidation number exists. In a peroxides, the oxygen having -1 oxidation number. In a superoxides, the oxygen having -1/2 oxidation number. Next, oxyfluorides. The oxyfluorides, dioxydifluoride exists +1 oxidation number. In oxydifluorides, +2 oxidation state. Next, last one, in ozonides, the oxygen exists -1/3 oxidation number. Okay. So different types of oxidation numbers are present in oxygen atom. In most of its compounds, oxygen atom exists -2 oxidation number. Okay, because of oxygen valency 2. Okay. So this is very important models of oxidation numbers. Okay. Next video lo వేరే కాన్సెప్ట్ చేద్దాం. ఓకే, థ్యాంక్ యూ.